Multiple interstellar objects have entered our solar system. Study finds. When Umama traveled through our solar system back in 2017, people around the world paid attention. It was the first interstellar object, ISO, astronomers had ever identified. After that, another one was found, and then astronomers came out saying many more will be coming through towards us. Now, then in August 2019, comet Borisov traveled through our solar system, becoming the second ISO to cruise through for a visit. Together, the visiting ISOs generated a wave of inquiry and speculation. There's no doubt there's bound to be more ISOs than just those two, and a new study says our solar system has probably captured some of these interstellar visitors, though they don't stay for long. Although ISOs are rare, the solar system is old and many have likely visited us. Astronomers think that some of these objects can be captured in solar orbits. This study takes a closer look at ISO capture and tests the idea that some ISOs could be captured in near-Earth orbits rather than solar orbits. The researchers behind the work say that there could be a steady population of ISOs in near-Earth orbit, saying interstellar objects present a unique mechanism to investigate the formation and evolution of planetary systems, including our own. Finding tiny objects in space is extremely difficult. The only images we get of the other solar systems are either of their stars or weak images of the odd exoplanet. Sometimes astronomers detect debris disks and other features, but fine detail eludes them. So it's nice that other solar systems send the odd involuntary emissary our way. Studying these ISOs is one way to gain insight into other solar systems and how they form and evolve. The authors of this paper say the ISOs provide a unique opportunity to investigate the formation and evolution of planetary systems, including our own. They also point out that whether any are in our solar system now is a major point of interest for astronomers. They write, although rare, ISOs can be captured into bound orbits by different planets in our solar system. The paper is Close Encounters of the Interstellar Kind, exploring the presence of interstellar objects in near-Earth orbit. The first author is Dipta Yoti Mukherjee, graduate student at Computational Astrophysics for the Physics Department at Carnegie Mellon University. The other authors are Hai Trak, Smear Siraj, and Avi Loeb. The paper has not been peer-reviewed yet. Recent research shows that the upcoming Vera Rubin Observatory could find up to 5 ISOs per year, interstellar objects per year, and that the Oort cloud, if it exists, might contain more ISOs than native solar system objects. Other research suggests that cosmic rays might erode most ISOs to nothing. Other papers have shown that many ISOs would be pulled into Jupiter and destroyed. But none of them specifically examined capturing ISOs near Earth orbits. The study is based on numerical simulations, where each particle in the simulation represents a potential ISO on a different trajectory originating outside the solar system. The simulations are based in large part on scattering effects, where an incoming particle is interfered with in different ways by the Earth, the Moon, the Sun, and Jupiter in varying combined ways. The research involves cross-sections of space and velocity that result in ISOs being captured in near-Earth orbits. The researchers call them capture cross-sections, and after a large suite of n-body scattering simulations, they identified the trends. And from their studies, they illustrate some of the particle simulations in the research. In their first scenario, the simulated system only consists of the Sun, Earth, Moon systems. Its purpose was to isolate the effect of giant planets. Their results show that massive Jupiter plays a very dominant role. The Earth, Moon, and Jupiter capture cross-section dominate the capture of interstellar objects into near-Earth orbits by a factor of 104 compared to that of Earth-Moon. And the researchers compared Jupiter's efficacy at capturing ISOs into near-Earth orbits compared to the Earth-Moon efficacy. The math is fairly complex, but basically it shows hyperbolic velocity, and as that rises, capture efficacy decreases. When the authors compared their results with the actual distribution of known small bodies in our solar system, something notable popped up. If the interstellar object were captured, it would likely end up with an average distance from the Sun greater than 10 AU. They point out that this is where the Centaur comets exist. The Centaurs are small solar system bodies with unstable orbits due to interactions with the giant planets. So could these ISOs be hiding among these Centaurs? ISOs hiding among Centaurs have been examined by Siraj and Avi Loeb in 2019, but no known Centaurs are considered to have an interstellar origin, they write. However, they said our study suggests a closer examination may be merited. Captured ISOs are not likely to have very stable orbits, they said. The team's data shows how ISOs could be captured into near-Earth orbits, but looking for them in these initial orbits might prove fruitless. And that would be too easy, wouldn't it? Nature seldom gives us its secrets so rapidly. We caution the reader that this is not a full representation of present-day captured ISO by Earth and Jupiter. ISOs captured in the past will evolve their orbital parameters over time due to interactions with other planets in the solar system, they explain. The team performed some long-term orbital calculations for a subset of captured ISOs out to 10 million years to test their survival. They plotted the survival objects in near-Earth objects. Some ISOs might escape their initial capture orbit into another capture orbit, but those ISOs fall outside this effort, they said. And once the captured ISO leaves its near-Earth orbit, it either leaves the solar system or takes up a new orbit with a larger perihelion and semi-major axis. But objects captured by Earth have an average survival rate 2 or 3 times those captured by Jupiter. If there are captured ISOs in near-Earth orbit, they don't last long. ISOs captured by Jupiter into near-Earth orbits have a half-life of about 50,000 years. Once captured by Earth-Moon have a half-life of about 130,000 years. Another way of looking at this is that the population of Jupiter-captured ISOs dwindles to 10% of the original fraction in only 800,000 years. For Earth-Moon capture ISOs, it's 2.1 million years. But many of these objects will be exceedingly small, nothing like Oumuamua or comet Borisov. The population is dominated by ISOs about a meter, that's 3 feet in diameter. There's no way that an object like Borisov or Oumuamua could ever be captured unless we did it artificially, they said. If we're going ever to find one of these captured ISOs, it'll be up to facilities like the Vera Rubin Observatory and its Legacy Survey of Space and Time. It's a planned 10-year survey of the southern sky that should begin sometime after its first flight in August 2024. According to authors, there could be more substantial population of captured ISOs hiding among other near-Earth objects. This demonstrates the need to study them in greater detail, and the best way to study them is go out and meet one of the larger ones. And this is on by Universe Today, even go on Science Alert. Please leave your comments. Thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.